You're on.
Okay. Let's do a problem that Mr. Snell has now given us the ability to do. So write this example, then I'll have you do a couple. Let's say that we have air going through glass. So let's start it. Air goes through glass. The N for glass is known. It's 1.5. Remember, we suspected that they would be greater than 1. So glass has an N. That's an index of refraction of 1.5. Let's say the angle of incidence is 34.5. And let's find the angle of refraction. This is the kind of problem we get when we're using Snell's law. So write down the scenario. Air goes into glass. Glass has an N of 1.5. The angle of incidence and the angle of refraction. All right, so in the theory, this is the angle of incidence. You go back to the formula and indicate this is the angle of incidence and this is the angle of refraction. So there's a relationship between them. With that knowledge, you could probably do the problem without me showing you. So you can zoom ahead if you want to. So I first write the relationship N1 sine of theta 1 equals N2 sine of theta 2. All right, N1, it started in air. They won't tell you the N for air, but we have decided that the speed of light in air and in a vacuum are the same. So anything divided by itself is a 1. So air has an N of 1. They won't tell you that. They expect you to know it. So N is starting in air. The sine of theta 1 is the angle of incidence. It came in at 34.5. Make sure you're in degrees. N2 is what we're looking for. We're asked to find, no, N2 is not what we're looking for. We're looking for theta 2. N2 is the value, the index of refraction to the second material. It went from air to glass, 1.5. It was given. It will be given in the problem, or we have enough to calculate it. Times the sine of the angle that we're looking for, the angle of refraction. I'll call it theta 2. So, mathematically speaking, you divide both sides, find the sine of 34.5, divide it by 1.5. At that point, I got 0.377. When I found the sine of 34.5, I got 0.566. I didn't write that. I will 0.566. When I divided by 1.5, I got 0.377. Now this does not mean to take the sine of this number. This is saying the sine of some number is this. So your calculator knows how to find that angle by the inverse sine button. So you go sine inverse of 0.377, and that should give you something around 22. All right. So this tells me that when this light beam came in, it was at 34.5 degrees, and when it went into the glass, it had this angle of 22. So, all right, our assignment then for the rest of the class, maybe, we can go on if we finish, is in the yo-yos. So we'll do 12.4, 5, and 6. And those answers are in the back, or I have them if you want to check against me, but I want you to see some success in using Snell's law. So,
More OYOs.
I should have done that. Should I turn it off?
let's show them the problems
Okay.
and the answer.
That's the math.
Oh yeah, that's right.
You can show them those problems. They might appreciate that.
Gets me going. I know, man, I can't live with you, sorry. Like people who eat ice cream, like, they should have like bite into it. I'm like,
Oh, no.
Nope. It's not really
Yeah, Billy,
When she was little, she got her feet left out in the ice skating rink. She ran into a wall.
She got stuck in the
No,
Alright, here's the problems.
Get them replaced, like no fillings and crowns and all that.
And I will
She has fake teeth.
shine a light on my answers, so
She's fake teeth?
Only like two.
here's 12.4.
Fake teeth?
No.
Four.
No, don't.
But like whenever she wants to intimidate people, she scratches me just like.
And you
Like-
just see like.
12.5. And 12.6. Alright. Hopefully, yours are coming out like mine. That's all for today. Bye. Thank you.